And this lecture is about the use of particles. Particles in Blender are a tool that has many functions and what you can do with them. I would like to show you today. First of all, we're going to need a particle system and we're going to use an emitter. Now that means, for example, we can now add a plane here, and maybe as a first example, we'll make a bit of rain. We duplicate this plane and move it all the way up. And here we now want the rain to come from out here and then rain down on the plane below. That means we select this upper plane and go to the particle properties. We say plus here, and then we have an emitter. Now, if we're going to let this run in the timeline, we can see that in principle, it's already doing what we want it to do. So the particles are sometimes emitted even in the way we would like them to be, but they are round. Now, how can we change the shape of these particles? Now, for this, we have to go into the render properties below, and we have render as halo. Now, we can switch the whole thing from render as halo to, for example, an object or a collection of objects. So first of all, we actually want raindrops to all look the same under the raindrops tag. So we can do this with an object for now. So we say render as object here, and then you can see under object, we now have to create an instance object that it will actually generate. But we haven't got that yet. So that's why we're going to add a UV sphere here for a moment, and we'll just push this to the side for a bit. Then we simply go into the edit mode and we grab the top point. We press O for proportional editing, and then we have to select sharp up here, and then we just pull it all the way up until it looks like a raindrop. Something like this. Now, then we go back to our plane and we say instance object raindrop, and if we now play that, you can see that we got some actual rain. This works quite well. But if we take a closer look at the raindrops, you can see that the shading isn't particularly great. So we have to do some shade smooth here, but you can see that not much is happening. And what is happening now is simply that our plane underneath has been smoothly shaded as opposed to our raindrop. And when you smooth shade a plane, the normals change just a little bit. Now anyway, it's not what we want right now. So any changes to these particles we have to do on the instance object itself. In this case, the raindrop. And you can now see that if I scale it up and down, the drops get bigger and smaller as well. Now, if I, for example, want to make this look like a raindrop more with a glass material, then I go into the shader editor and the instance object here as well. That means I click new, and then you can look at the whole thing like this, and then we can see how everything updates. Even if I enter any color here now, you can see that this also updates in the particles. This means that we can now simply pack a glass BSDF into the surface output, and then we have our rain material right here. Now we can turn up the roughness a bit, we can always click on shade smooth, and then the whole thing actually looks like a raindrop, and you can see now it reminds you more of rain. So anything you want to change about the particles, you actually have to change in the instance object where it starts with. We do have to look at some other settings though, because how many raindrops do we want? And we can set that right here. We don't want 1,000, we want 10,000, and that's 10 times as many raindrops. And now you see some heavy rain going down, but I don't think it lasts long enough, doesn't it? Well, that's not what we want. So what we can do is we can set it here in frames. We can go to a start and ending frame, and we can have a frame start from 1 and an ending frame at 200. And that means that at frame 1, the particles will start dropping, and they will stop dropping at frame 200. So if we want to drop all 10,000 raindrops in the first frame, then we simply select frame start and end, and we both say 1. And then you can already see at the top that we have 10,000 raindrops falling down at the exact same time. And that means that we can create animations like this by using it this way. There's a lot more here, but I'll show you the rest of this later. What we're going to do is we go back to our rain, so we have frame start 1 and frame end 1, and we want to change that. So we set the frame end to 250, which means that our 10,000 drops are now spread out to 250 frames. And then there's the lifetime value. Now the lifetime value simply determines how long the particle stays in the scene. That means if I grab the lifetime value and just change it to 10, you can see that these particles are all sort of erased before they could even touch the plane at the bottom. So that means everything already gets deleted in advance. That means if I change it to 30 or something like that, you can see that raindrops are being removed somewhere around the middle part. So we gotta find the sweet spot, and once we hit that just below our plane floor, we can minimize the CPU load a bit without affecting the render result. So something like this would be perfect. This means that if this is now going to be an elaborate particle simulation, we can simply save CPU because it doesn't rain down through our bottom plane. It stays right here. Anyway, we still have the source settings here, and currently it says emit from faces. We can also convert the whole thing to vertices, for example, and if we look at what's happening here now, you would expect exactly the thing that is happening. It's no longer at the center of the surface, but at the points on the outside. It looks completely stupid, but I just wanted to show you so you get an idea. Now, another thing that's interesting is how these raindrops are distributed. If you look at the form distribution at the moment, we can see that it's completely random. So it's basically just a new pattern that Blender creates on this geometry. So it's really completely random. Can you change that? Can this be done in an orderly manner? Yes, you can. You can change the distribution from jitter to random. Sorry, it wasn't random, it was actually jittered. Sorry for not explaining that. Now it's random. And I'm also not entirely sure what the difference between random and jittered is. In any case, you can also pick the grid, and then we can set a resolution of our grid here. Then we can also set a hexagonal grid. So we have all sorts of options to guide our raindrops in an orderly fashion. Now, if I say here, for example, I want to emit 200,000 on the first frame and it was in a grid format, then you can see right here what happens. You can do a lot of cool stuff with this. This is also something I used in the animation you see right now, but as I said, I'm going to go into this at the end of this lecture. Now, with the random slider, we can actually do some other things as well, which are really cool because we can bring a little bit of randomness into the grid. It's sort of a grid, but it's imperfect by using this slider, and this means that we can set the order of our emission of particles very precisely precisely here, and that is definitely very helpful. So you might be able to imagine what you can do with all these functions in different situations. Okay, let's put the distribution back to random, because that's what rain does after all, and we're gonna emit it randomly, and if you set a certain dynamic paint canvas on the floor and a dynamic paintbrush for the drops, you can switch the canvas to waves, and then you can do something like this, for example. I'll be talking about the dynamic paint stuff at the end of this section. So our raindrops are falling down now, and they're looking pretty good, but now the question is, can they do something other than just fall down? Well, first of all, it's raining. I mean, it makes sense that they only fall down. Rain normally doesn't go any other way. But actually, there's many other options under the physics option that you can use. For example, different forces. There's the Brownian force, for example, which, when we turn it up, causes our raindrops to be kind of deflected a bit. It scatters it. And that means there are still a few left and right past our plane at the bottom. And if I turn up the Brownian force even more, you can see what happens. Our raindrops are basically falling past our plane on the left and the right. And then we have drag and damp here as well. And dampening is like air resistance. If I put it all the way up, you can see that our particles are now going out very slowly and have to fight really hard to get down. And that's what determines the vapor value. It makes relatively little sense for rain now, but there are bound to be uses for this somewhere. Now then, we also have the option for deflection below under physics, and here you can already see size deflect or die on hit. Now, we can now set all of that here, and that means we can now set up a collision collection. That means I can make a new collision collection that's just collection 1, and I'll take that into this collection now. I'll just pack our ground plane in, and now what we can do is just say die on hit, and this means that all our raindrops that come onto our plane at the bottom collide with this, and they will be killed instantly, so they won't return anymore. It doesn't seem to be working though. Why is that? That's because we haven't set the bottom plane as a collision object yet. When we've done that and look at the whole thing again, we can see that our raindrops are killed as soon as they are colliding with the floor. That means even if we look at the whole thing from below, we shouldn't see any raindrops coming through the bottom anymore. At least, well, maybe a few dots, but whatever. So much for that. There's still a few settings options down here in the render, as well as in the rotation. That means we could set a rotation here, for example, a random rotation for our raindrops. However, there's relatively little sense in doing that, because raindrops always fall down in the shape of raindrops are like this because they fall down. So this is not exactly realistic, but whatever. Maybe I'll just do a second example to show you what I mean. I'm gonna make a monkey in, we're gonna pull it in here, and then monkey 1 is going to be blue, dark blue, there we go. And then we want our monkey edges right here, and that means I'll change the name of the monkey to Suzanne. Now we're going to render a lot of Suzannes here, and also with some random rotation, which means that they don't all come straight down. That means that for such a simulation, for example, it would be absolutely sensible and helpful to do so. Now, if I put them down here again and then let the whole thing play out, you can see that they all fall down at the same angle, and that might only make mediocre sense for a simulation like this. So we can go up to randomize, and with this example, I can now explain or demonstrate scale and scale randomness. Scale is simply a multiplier for our particles. That's kind of what we would have expected. If I now simply duplicate this monkey and I say S 0.05 here, then you can see that this monkey has exactly the same size as the monkeys in our particle system. That's just a scale multiplier. So in other words, if I set it to 1, they will all become exactly the same size as the instant object with the scale randomness. And we can now do exactly what you would imagine. We can make a few bigger and a few smaller. 0.05 is the limit. And if I now increase the scale randomness, then you can see that they all become a bit smaller, but to different degrees, so to speak. But I think it's time to do something useful, as opposed to letting monkeys rain from the sky. So for example, we're going to create some snowflakes and let those snow down. Now we want to create a new collection, and this collection is called snow. And in this collection, we want to put the colleague here, and also another colleague here, and another colleague snowflake here. And then we select our second particle system here, we go to render as collection here, and we take the snow as an instant collection, and then you can see that we have the snowflakes falling from the sky here. Now we can play around again with the scale and with the scale randomness, and I believe the rotation in snow is also random. So that should all fit together well, and the material fits because it's just a basic white material, which is what snow is. In the viewport display, there's also the option to activate or deactivate the emitter, and what that does is pretty much self-explanatory. Now we also have the option to set children, but I think that's a bit stupid for particle simulation in my opinion, so that's it for the basics of particle simulation. A possible application example for this would be an hourglass, like the one I made here. So I created this little animation in Blender, for example, this animation that I would like to explain to you. And with that, here we are in the Blender case for this simulation I made. I have a kind of transparent PNG of a stone, and particles are then emitted from it. I'm just gonna go through the settings for this very briefly. We have 1,000 particles that are emitted, and they're all emitted at frame 1, and we already got to know that. The distribution is on the grid. The resolution is 100, there's no scale randomness, and the instant object is a sphere. However, the shading of these spheres now becomes interesting, because we're currently rendering the whole thing in Eevee because we're in the material preview. Now, if I switch to cycles here, you can see that all of these particles actually have the right texture. So that's one thing that was very important to me in this simulation, that practically the color of these individual particles corresponds to the color of this stone. So that means when you zoom out, you hardly see any difference. If we go into the material preview here, you can see these black renders here, and that was just practically the transparent PNG in a square plane, which I then subdivided. And then I simply deleted the faces on the outside, I shall say roughly, so that an unnecessarily large number of particles are not emitted here. When I say activate now, you can see that there's still a few particles out there that are transparent, or this particle here, for example, which is almost completely transparent. The question here is, of course, how can I actually render this now? Now for this, we have to look at the shading for our instance object, and that's the sphere. I think it's right back here somewhere. Here's our sphere. So how does the shading look here? I have the picture, and we have a mapping node here, and we have the generated coordinates that go into the vector, and then you can set an object down here. And then I chose the plane here as the object, so that's the transparent PNG. And then it is very important that you ticked from instancer down here. If you don't do that, the UV map will be created separately for each individual sphere. The from instancer option is unfortunately only available in cycles, otherwise I would have rendered the whole thing in Eevee as well. Now I can switch to Eevee and then we can see what the whole thing looks like. And they have the problem that we see again, the texture is completely unwrapped once per particle. So to reiterate, this from instancer option is only visible in cycles. Now I just want to open a new project for a moment to demonstrate it again from scratch, so to speak. This time, however, we don't want the particles to fall down, but rather to be emitted to the right, because I want to show you some cool stuff with the physics that we still have here. Maybe this time we'll do cubes, so we do voxels, you could say. Now we select our plane, and we add an emitter, and then we say render as object, and the object should be our cube. It all looks like this at the moment. We want to have significantly more particles, 100,000 or so, really a lot. And then we want to turn off the gravitation, because the gravitation annoys us a bit here, so that our particles are only emitted in one direction here to the right, so to speak. So this way it goes to the right and it looks a lot better now. Our simulation is also going a bit slower now, and I'm just not in the mood for that, so that's why I'm doing a bit less at the moment. Now we want each and every one of these cubes to be the color of the pixel that will then mimic it below, so that in the end I can also recognize our image within our particles, so to speak. Now we get our cube, we go into the shader editor, and we switch from world to object. We click new, and we give us an image texture. Now we already uploaded our image here, this is the pack, and we pack this in the base color, and now we have what we would expect once again. So say the image is unwrapped equally on all cubes here. Then we go with the node wrangler activated, we press Ctrl T, and then we set the whole thing to generate it. Now the object is our LPF thing, the plane from which we imitate things. And then we want to activate from instancer and go to the cycles mode. And when we've done all that and then position ourselves here, for example, then we can see that the particles are emitted here actually colored exactly as we would like them to be. And we deactivated our gravity in our scene properties. Now how can we keep messing around with the physics here? First of all, the velocity is calculated here again by the normals, or by the one normal vector of these planes, because these planes only have one normal vector and it points in this direction. I can also show you that by turning on the whole thing up here, the face orientation. Blue is the side that it's moving towards and red is the side it's not. Now if I go into edit mode and have the normal displayed here, I could see that the normal vector points in this direction. Now we can also go to normal and flip under mesh at the top, which means that the whole thing is now being sent the other direction, and this calculation of 1 meter per second is calculated linearly in the basis, in the direction of the normals. This is what the program normally does. Anyway, here we have our simulation, and that's all fine and dandy. However, we can get creative again here, for example, with force fields. In general, everything that we did here with the physics so far can also be supplemented with force fields. Doesn't matter which simulations we have, whether it's rigid body simulation, cloth simulation, particle simulation, fluid simulation, or soft body simulation, we can always work with the force fields to make things more interesting. Now, I haven't mentioned this every time, but your simulation always responds to the force field. This means that if I set a vortex here, for example, and I rotate it, the whole thing starts from frame 1, and then you can see that the whole thing is now rotated just as you would imagine with a vortex. I could set the strings to 1 here, and then everything would be a bit friendlier. Now, you can also have a lot of fun with that and create a lot of very cool effects that you might be thinking about now. That was it for the particle system so far. Next up, we're going to be looking at hair particles. Let's go.